All right, guys. So today we're going to be moving on to linear inequalities. We've been doing stuff with compound inequalities, which are like two inequalities that either cross each other or go away from each other, etc. But those are all inequalities that exist on a number line. Today we're going to be going over how to do things with inequalities that are in two dimensions. So I'm going to show you what those look like. The resource that you guys should use is this website, desmos.com/calculator. It's a really good online graphing calculator. It's free. It works pretty well on your phone. You don't really need an account to use it. As you can see, I'm not signed in or anything. So the first thing that we're going to start with is y is greater than or equal to. So to type that in, you both hit the greater than symbol, which is near the bottom right of your keyboard, and the equal symbol. Negative 3x plus 2. There we go. So we can see how this starts at 2, and it goes down 3 over 1. So that's like a normal, graph. But we also have, not only do we have this line in red, but you also notice that we have this big shaded region over here to the right. And so the way that these are going to work, much alike to how in a normal inequality, there's an arrow that describes the space that is that are solutions. So for instance, if x is less than 5, the arrow goes to the left, and those are all of the things that would work for x. This means that this entire shaded area, all this stuff over to the right, that all counts as solutions to this set. So for instance, if I typed in a point such as, let's type in the point like 3, 4, so we see this point over here, that point is a solution to this inequality because it's in the shaded region. If we had, let's do negative 3, 4 instead, you can see how this dot over here, that dot is not in the shaded region, and so that's not going to be a solution to that system. So that's step 1. Step 2, we're actually going to make a system out of this. So instead of just leaving it at 1, all we mean by the system thing is that we're going to have a second inequality. So we're going to do the inequality y is less than x minus 2. Okay, so we should notice it starts at negative 2, goes up 1 over 2. Something that we should notice now, though, is that, well, there are two things. One of those things is that, go out a little bit. One of those things is that the inequality here, you can see how this one's a little bit different because this one's a dotted line instead of that solid line before. Now, the main difference between these two inequalities, well, there are two things really, but one of those things is that this one is greater than or equal to, and this one is just less than. So if I was to redo this one, I'm just going to put that as greater than, you can see how it's also a dotted line. So one of the things that you have to pay attention to, the equal to, is whether or not something's equal to or not. If something's equal to, we actually have a solid line. It's kind of like how in the regular inequalities, how you have the filled in circle for when things are equal, and you leave the circle open when they're not. So that's one thing we need to pay attention to. The other thing, this has y is greater than, and this one has y is less than. The bottom one has y is less than. And you notice how these are shaded differently. So on this top line, for this y is greater than negative 3x plus 2, this means that we're going to be shading above that line. So you can see how this line that goes down pretty steeply, we shaded above that. All of this stuff is a solution to that region. And on the second one, since y is less than x minus 2, we shaded below that region because the y values are going to be less than that stuff. So the final step, if we're talking about a system of inequalities, this right here in front of us is a system of inequalities. You can see just two inequalities. That's basically what a system is. So to be a solution to a system of inequalities, the point solutions to linear inequalities are now points, but that point needs to be at least, it has to be in both inequalities at the same time. So for instance, the point, let's do 6, 1. So this point over here, well, that point is going to be a solution to the system because it is simultaneously a solution to the red line, the y is greater than negative 3x plus 2, and it's also a solution to the second one, the y is less than x minus 2. So this point is a solution to both things at the same time. If we were to change that, I'm just going to change that a little bit, make that a negative 6, 1. So you can see how this one's not shaded at all. That means that this point is not a solution to either point, or either line. So that means it's definitely not a solution. But the things that people get a little bit confused on, so for instance, let's have a point like 3, 4. There we go. This point, it's shaded, but it's not shaded twice. And that means that it's only a solution to one of the two inequalities. That red one up there, that red inequality, that's a solution. That point is a solution to that inequality, but it's not a solution to that purple inequality. And that means that it's not actually going to be a solution to the entire system, because to be a solution to the entire system, it has to be a solution to both things. So that's how you find if something is a solution. So this one is a solution. We can count that as a solution. All right, let's show a couple other examples. So for the next example, we'll do y is greater than 1/3. So we have that, x plus 2, we'll leave the rest, and y is, we'll do another greater than symbol, negative x minus 2. So figuring out some points. For instance, a point that would be a solution. Let's think of one we can go over in this area so we can see all this stuff that's double shaded. How about the point, let's see, 3, 3. So let's think about this point. This point, 3, 3, it's near that shaded region, but we can notice that it is also on a solid line. So we need to think about, if something is on a solid line, do we actually count that point as a solution? Now, if we look at this graph, this one's being described by the y is greater than or equal to 1/3 x plus 2. So that means that that point is on a solid line, because that point is on something that is greater than or equal to. And if you remember back to inequalities, whenever something's equal to, we actually include all those, we actually include that point. So in this kind of example, because we have a solid line here, because it's equal to, that means that we include all of those points along that solid line. So all of these points, points like 3, 3 and 6, 4, etc., all of those points are going to count. However, if we were to change this, so let's find a point that's on the dotted line, so that would be like negative 5, 3. Yeah, that works. This point over here, it's on a dotted line, and all of those points that are things like y is greater than negative x minus 2, since it's on a dotted line, we don't actually include any of those points. And so that point in particular, we're not going to actually include in our solution. So this thing over here is not a solution. And the final question, if we were going through this, let's think about this one. The point negative 3, 1, well, that's where the two lines cross. So we need to figure out, in this kind of instance, it's kind of strange, but in this kind of instance, which one of the lines matters more than the other one? It's kind of a weird question. But what we're asking is, does it matter if it's on the solid line, do we include it? Or because it's on the dotted line, do we not include it? And in fact, in this kind of situation, if it's on both lines, that means that we don't include it, because you have to make sure that you don't include anything that's on a dotted line. In the same way that you wouldn't count something like that point down there. That's still kind of on, like negative 6, 0, still kind of on a solid line, but it's not really in the solution set. So you wouldn't count this thing over here, the negative 3, 1, because it's not in the solution set, because it's on a dotted line. So that's one of the other things that we have to pay attention to. So the questions that we're going to be asking, I'm actually going to be presenting to them to you in this kind of way. So I'm going to ask you to graph two different lines on Desmos. Just graph them using this kind of resource, and make sure to use your symbols, make sure to use them correctly. And then once you graph them, I want you to be able to tell me whether or not some point is a solution or not. So remember, it's a solution if it's in this double shaded region, if it's in that region up there, and if it's only shaded once, or it's on a dotted line, it won't count. So that's going to be about it. Good luck. If you guys have any questions, please come to my office hours at 11 o'clock and 1.